Bismillahirrahmanirrahim. Assalamu alaikum and greetings to all honorable colleagues. My name is Dr. Wasiq Hussain. This is my picture. Welcome to my talk and thank you very much for joining me in the seminar. I'm really grateful to all the honorable organizers of this 22nd International Pure Mathematics Conference, especially Honorable Professor Emeritus Dr. Kaisar Mushtaq Sahab and Honorable Dr. Said Sahab for encouraging me to speak on this important topic. I hope that honorable audience is going to enjoy my talk for the next 20 minutes. So let's start the enjoyment. I'm Professor of Mathematics at Foreign Christian College, a Chartered University, Lahore. This is Ermakos Science Building where my office is located. I did PhD in the field of applied mathematics and specialization is in elastic waves in 2000 from University of Glasgow, Scotland, UK. Here's the picture of University of Glasgow. Before that, I did MSc and MPhil in 1993 and 1995 respectively from the Department of Mathematics, Quaid-e-Azam University, Islamabad. So I'm a Quaidian. All these achievements from the last century. Let's go further. Here's the title of the talk. Fun way or runway using technology for effective teaching in mathematics, online and face-to-face. Let's try to understand the meaning of the topic. See this jumping castle. Children, they're enjoying over it. Definitely they're going to be tired. Then they leave, but they do want to come back because they're enjoying. They have fun. Then what is runway? Something like this when one is scared and running away. Unhappily, maybe from mathematics. Oh, so many questions, so many formulas. Teacher was going very fast. Oh, I couldn't do that. What should I do? But topic says using technology for effective teaching in mathematics. Word effective is very, very important. It could be simply using technology for teaching in mathematics. Effective means something really productive, fruitful, useful, and it's used online and face to face. See this? One of my students is watching my YouTube channel and that was developed during COVID-19 lockdown. Here Mr. Corona is sitting and this is online. This is the online case. Regarding face-to-face, see this. This is face-to-face. See, projector is over there, white screen is there, and yes, technology is also being used face-to-face. Now, how to make the use of technology effective for teaching in mathematics? Here are important tips to make teaching effective by using multimedia projector. Here's the multimedia projector. In multimedia lectures, animations can be used so that a few lines or pictures should appear at a time, but not the whole slide, as going on in this seminar. Animations is an inbuilt feature in the Microsoft PowerPoint by which several objects like sentences, mathematical equations, cartoons, pictures, they appear like moving objects. While projecting the image on a wide screen, it is always helpful to use pointer or the laser pointer to indicate the things being explained. Here's the picture of the laser pointer. I'm using laser pointer now. My cursor is acting as a laser pointer. By this, audience feels comfortable as they know if speaker is explaining at the top or the middle or at the bottom of the slide. Where required, key points can be written on board. Working can also be done on the board, like this. See this. But no need to write every detail as it is already available on the slides. This helps students a lot if they ask anything and instructor says that was on the previous slide or 2 slides before the current slide. Now, are there any benefits of what we are doing or what we are trying to do? Yes, there are benefits. This says both energy and time are saved for instructor and students. When we talk about saving the energy, we get something like this. And when we say saving the time, then something like this. Well, this is for fun, but the question is how? How can we say that the both energy and time are saved for the instructor and students? Question is still there. See, a person is thinking. Here's how. For the instructor, time and energy spent in writing on board are saved in explaining the concepts. This gives more time to instructor to drop down at students level for concept clarity. Similarly, for the students, time and energy spent to copy from the board are saved in understanding the concepts. Students won't be under stress to copy everything from board before instructor erases everything. They get more time to understand the concepts, raise the questions, asking the questions. Now, one might be thinking, okay, students don't have to write anything. How do they get the notes? No problem at all. See, soft copies of lectures, important handouts can be saved on the pen drive instead of carrying hard copies. And preferable are PDF files. See? So instead of carrying bundle of notes like this one, which unhappily we start doing at the school level, one can put all the notes, all the soft copies on this pen drive. And the soft copies which are saved on pen drives will be used as a useful source of knowledge whenever and wherever required. After teaching my classes, I think a lot about the following points. This is my thinking style. The first and the most important point, can I understand myself as a student if anyone teaches the way I teach? This is called self-assessment. If this happens, then there will be no complaint from students going to higher authorities to change their teacher. Number two, basic concepts should be clarified. Otherwise, advanced topics are not understandable and problem solving skills won't develop. See, there is a star over here. I am dedicating this point to my late father, famous as Dr. C. Hussain, Dr. Chaudhry Muhammad Hussain from 1927 to 2009. This is his picture. Honestly speaking, when I was in intermediate, I decided to leave mathematics, and the only reason was teacher was going very fast. At that time, my father explained the theory and concepts on which formula was based. He explained the logic behind a particular mathematical method. He explained the proof of the theorem. And that was the turning point of my life. I decided to do PhD in mathematics, which I did, and now, by the grace of God Almighty, giving a talk in international conference. And here's an interesting information. My father played very important role in developing the mathematics department of Quaid-e-Azam University in 1968, and he served this department from 1968 to 1987. Point number three, teaching lesser contents at a reasonable speed is much better than covering too many contents at a very fast speed. Now just have a look over here. Reasonable speed less than 60 miles per hour. Oops, this is very fast. More than 180 kilometers per hour. Of course, this is not comfortable. The first one is comfortable. Again, that is for fun. But the important point is, wherever you are teaching, you have to keep the speed or pace of the course reasonable so that students should feel comfortable. There's a very famous saying, some people are wise, rest are otherwise. Otherwise, what will happen? This will happen when you cover the whole syllabus in one night, then this will happen. After saying all that, now let us understand some mathematical concepts, topics using technology. Let's start with a very simple example. Unhappily, sometimes people make fun of mathematics that y negative times a negative is a positive. This thing, negative into negative is positive. Why? Here's a very simple explanation using technology. If x is any non-zero real number, then we divide x over x. The answer is going to be 1 as long as x is not equal to 0. Division by 0 is not defined, is not allowed, right? So this means when you divide any real number by itself, answer is 1. This real number can be negative. So this means 2 upon 2 is 1, then minus 2 divided by minus 2, again it is 1. And this is equivalent to minus 2 multiplied by 1 over minus 2. This is same as minus 2 multiplied by minus 1 upon 2. So negative is positive. This is a very simple explanation, but unhappily from the school level, most of the students, they memorize that negative into negative is positive. And honestly speaking, I'm not teaching in the classroom, otherwise I should have gone slower. I'm going very fast now. Secondly, one should try to relate such examples with a real life situation. See this. Here's a daily life example to understand this. Your enemy's enemy is your friend. So negative is positive. See this. Here's the enemy. There goes negative. Here's enemy. Again negative. Here's the friend, red alert, positive. So this is one simple example. Infinite sequence. See, I'm not going to teach over here. What I'm saying over here is, this is my humble request that the definition of a convergent sequence is always troublesome, the abstract definition. Unhappily, I have seen many students memorizing that. So I'm going to give a technique over here to make them understand this definition, and they should not be afraid of that definition, and that definition really become interesting. So as we know that infinite sequence, it's a function f whose domain is the set of all positive integers or natural numbers. Here's an example. See, the domain is set of natural numbers and the range is going to be the real numbers. N is 1, 2, 3 and so on. N is a natural number. So here's the domain 1, 2, 3, n and so on. And for this example, here's the range. When you substitute 1 over here, 1 is going to map on 1. If you just substitute 1 over here or the 1 over here, so f of 1 is 1. There it is. When you substitute 2 over here, then 2 is going to map on 1 over 2. When you substitute 3 over here, 3 is going to map on 1 over 3 according to this formula. And of course, the image of n is 1 over n under this function. So nth term of the sequence is denoted by an, right? So the first term we obtain by substituting n is equal to 1. When you substitute n is equal to 1, we get 1. This is the first term. When you substitute n is equal to 2, you get the second term. When you substitute n is equal to 3, you get the third term. When you substitute n is equal to n, you get the nth term. And a sequence is denoted by enclosing the nth term in brackets, which means a1, a2, a3 and so on. And this is the notation for a sequence. Instead of writing like this, we simply write like this. Here's a convergent sequence. In the convergent sequence, limit of the nth term exists. When you take the limit n goes to infinity, then limit of an exists and is unique, right? We say that the sequence converges to the number L. For example, if we take this sequence, then yes, limit n goes to infinity, 1 over n, this is 0, right? This is acceptable. But here comes trouble. What is trouble? This abstract definition of a convergent sequence, which says the sequence whose nth term is an converges to the number capital L if for every positive number epsilon there exists capital N such that absolute value of an minus L is less than epsilon for all small n greater than or equal to capital N. If this definition is not understandable, then it creates mind stress. Like this. Or like this. and unhappily mind explodes. In order to avoid that, we have to go towards concept clarity. So let us understand the definition of convergent sequence by considering a simple example already discussed and is given by limit n goes to infinity 1 over n is equal to 0. 0 in this case is capital L. Nth term is an, which is 1 over n, and this sequence is convergent to 0. Consider again the definition of a convergent sequence. The sequence whose nth term is an converges to the number capital L if for every positive number epsilon there exists capital N, such that absolute value of an minus L is less than epsilon for all small n greater than or equal to capital N. Definition clearly says that epsilon is already given. It says for every epsilon positive. When epsilon is given, we have to find capital N such that this inequality holds. So let's try to find capital N for this example, in which the nth term of the sequence is 1 over n and the limit is 0, which is capital L, and an is 1 over n. So for any epsilon positive, we shall try to find capital N such that absolute value of an minus L, that is going to be less than epsilon. In this case, the nth term is 1 over n, which is written over here. Limit is 0, which is written over here. And 1 over n is positive, so absolute value is again 1 over n. So let us choose epsilon. Let epsilon be 1 upon 3. And of course, 1 over 3 is positive. And we have to find capital N such that this inequality holds for epsilon 1 over 3 for certain value of capital N. So consider the first term. When n is equal to 1, substitute n is equal to 1 over here. The first term is going to be 1 over here, which is 1. Absolute value of 1 is 1. And what is epsilon? 1 over 3. And we have to check this inequality. So is 1 less than 1 over 3? Of course not. So let's throw a javelin. Here comes javelin. It's not less than 1 over 3. Let's check the second term for n is equal to 2. Now the absolute value of a2 minus L is equal to 1 upon 2 minus 0. L is 0 as we saw from here, and second term is 1 upon 2 as we can see from here. So absolute value of 1 over 2 is 1 over 2. Again, is this less than 1 over 3? No. So continue like that. Consider for n is equal to 3, the absolute value of a3 minus L, which is going to be 1 over 3. Is this less than 1 over 3? Again, no. Get ready for the good news now. Now see this, when n is 4, nth term was 1 over n. So fourth term is 1 upon 4. Limit was 0. The absolute value of 1 over 4 is 1 over 4. Yes, this is less than 1 over 3. Congratulations. And note this inequality. Further, for n is equal to 5, a5 minus L absolute value. Again, this is 1 over 5. Again, this is less than 1 over 3. And so on. Now, inequality holds. Which means that absolute value of an minus L, which is going to be 1 over n, this is less than epsilon when epsilon is equal to 1 over 3 for all small n greater than or equal to 4. So for epsilon 1 over 3, capital N is 4. Similarly, if epsilon is going to be 1 upon 4, then the absolute value of an minus L, that is going to be the absolute value of 1 over n, which is again 1 over n, that is going to be less than epsilon, where epsilon is 1 upon 4 for all small n greater than or equal to 5. And 5 is going to be capital N over here. Because if we substitute 1, 1 is not less than 1 over 4. 1 upon 2, not less than 1 over 4. 1 over 3, not less than 1 over 4. 1 over 4, not less than 1 over 4. 1 upon 5 is less than 1 over 4. So n is greater than or equal to 5 when this inequality holds for epsilon 1 upon 4. So capital N is 5 when epsilon is 1 over 4. So that's it. So for any epsilon positive, we can find capital N such that this inequality holds. What is the inequality? absolute value of an minus L, that is going to be less than epsilon, and that is going to be less than epsilon for all small n greater than equal to capital N. For given epsilon, we can find capital N. So just cut this apostrophe T that I cannot do it. Say I can do it. Do it what? Give me epsilon, I can find the capital N such that this inequality holds. Hooray! 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 It's a holly, holly day. I understand convergence sequence. Holly, holly day. So here's a success. One should celebrate. Here are student comments from the course evaluations. First one says the use of multimedia is the best way of teaching students, and other teachers should follow this method. Second is, I'm really thankful to the teacher and his effective way of teaching using multimedia. It has alleviated my fear of long and scary looking mathematical equations. I like the way he concentrates on the proofs and roots of the concepts. Alleviated means reduced. Well, this was not part of the evaluation. I put it myself over there, this diagram, in order to explain the meaning of alleviated. Here's another feedback from the students. The way of teaching with multimedia is really effective and the concepts got very easy to grasp. Grasp means strong grip. Using multimedia in classroom is really a good idea, so we don't have to put efforts in writing and concentrate fully on learning. These are student comments from course evaluations, but during face-to-face teaching. Here are the issues which were being faced for online classes during COVID-19 lockdown. First one, weak internet signals, or maybe no signal at all, so really difficult to join an online class. Second, sometimes inaudible sound, maybe noisy sound, or no sound at all. Third, sometimes power failure, so again really difficult or maybe impossible to join an online class. Now the question is, what do I do now? The answer: using technology for effective online teaching during COVID-19 lockdown. Here's Mr. Corona. That's what I did. I recorded my lectures in the same way as I deliver face-to-face in classroom. And if required, I made extra slides as no whiteboard was available to write the key points. As I mentioned before, that it's always better to write the key points on the board, but as on online classes whiteboard was not available, I made extra slides. And I recorded my lectures on Microsoft PowerPoint. There is an inbuilt feature in Microsoft PowerPoint to record a video. I edited the video using video editor and finally uploaded on YouTube. This is my YouTube channel, Dr. Wasiq Hussain, Mathematics with Music. I also play flute, so one can find my flute performances over there as well. Students can watch at their convenience. There was no compulsion on time when they have to watch, whenever internet is available and whenever electricity is available. I didn't take any Zoom session or any online class, but for course queries and to remove the difficulties of students, I stayed in touch with my students via email and WhatsApp. And on WhatsApp, I made groups for each course, but that group was only for the teaching purpose. Now, here are student comments from course evaluations, this time during COVID-19 lockdown. First one says the whole process of giving video lectures was so conducive to learning or made possible to learn for the students that everyone was able to learn at one's ease. Second says I found no difference between online and on-campus classes. I really appreciate the efforts of making videos, editing, and uploading on YouTube. Third says YouTube lectures are the best because we can listen more than once if we stuck at any point. And if any student due to lack of confidence don't ask questions to the instructor, then he or she can listen the YouTube lectures more than one time to clear the concepts. So that's all from my side. Thank you very much. Goodbye and Allah Hafiz.